Hi, welcome to the video solution for physics past paper. This is Edexcel IAL, Unit 2, October 2017. Let's start. Question 1. The spreading of a wave as it passes around an obstacle is called. This statement is definition of diffraction, meaning when wave passes through some obstacle or some gap, the wave spreads out. So this is diffraction. So unit option is A. Question number 2. Unpolarized light with a power of 8 watt is incident on a polarizing filter. What is the power of light after passing through the filter? So what is happening here? Some unpolarized light is passing through a filter. That means after passing you have polarized light. And you need to understand the relation between power of light and polarization. So this relation is not in your specification because you need a serious calculus and differentiation of understanding this relation. But for you just memorize that for polarization, power becomes half of the previous value. So if the power was 8 watt and it becomes 4 watt after polarization. 3. The current I through a wire is given by I is equal to NAVQ. Which of the following is the correct statement for N? N has no unit. It is wrong statement because N has a unit. N is charge density. So N has a unit meter minus cube, number of charge, number of electrons per unit volume. So per unit volume, that's why you have a unit. So statement A is wrong. N is equal to the number of charge carrier. It is also wrong because this is incomplete definition of N. N is number of charge carrier per unit volume. So A is wrong, B is wrong. C is N is dependent on the material of the wire. Yes, of course, because how many charge are there in a given material depends on type of the material. So C is your correct option. Four. The four diagram represent moving wavefronts that are one wavelength apart. In each setup, diffraction will occur as the wavefront passes through the gap. Which setup will produce greatest diffraction? Greatest diffraction or most diffraction depends on relation between gap size and the wavelength. If you see you have this much gap in the given option A, and this much gap is, so the wavelength and the gap size, you need to see each and every diagram which shows lambda wavelength equal to gap size. So if gap size is equal to the wavelength, then you have a most diffraction or greatest diffraction. So clearly option C, in which you see that this is the gap size and this is the wavelength. So both are similar, or both have the same size. That's why at C you have a greatest diffraction. So option is C. Question number 5. An electric motor is being used to lift a load. The total input energy of the electric motor is En. Input energy. Some of the energy is transferred to useful gravitational potential energy and remainder to wasted energy EW. The efficiency of the motor is given by, efficiency is output energy out divided by energy in. So energy out is your gravitational potential energy, that means useful energy divided by input energy, and input energy is the sum of gravitational potential and the wasted energy. So E in is in fact E grave plus E W. So E grave divided by sum of these two. So your option is B. 6. A wire has a resistance of 8 ohm. A second wire has a twice the cross-sectional area, twice the length, twice the resistivity. What is the resistance of the second wire? So in this case, you need to know the relation between area, length, resistivity, and the resistance. So formula of the relation is R is equal to rho L by A. And suppose this is the resistance of a first wire R1 and resistance of the second wire R2. So this equation can be written as per given condition: resistivity is double, length is double, and area is also double. So clearly you can cancel 2 and 2. Finally you have 2 rho L upon A. This is L, length, and this is R1. That means resistance of the second conductor is double of the first conductor. So this is 8, double of 8 is 16. Option is C. Question 7. The energy E of a photon is given by E equal to hf. The SI base unit of H can be given as. So if you see your data sheet, H has a value 6.625 or 6.63 10 to the power minus 34 joule second. This joule second is SI unit of H. So you can find from these joule second, you can figure out the base unit after converting joule into base. So you can rewrite joule as Newton meter, because joule is Newton meter, force into distance. M is the distance, meter, and second is there, this second, and Newton meter is in place of joule, and Newton is F equal to ma. That means kg meter second minus 2, and this meter is there and this is second. And if you simplify all these variables, so kg meter meter square, second minus 2, and second minus 1. So your option is A. Or you can use similar the given equation to figure out the unit of H. So you can do that. H is equal to energy upon frequency, and energy is joule over frequency, and frequency is hertz. Moreover, joule is again Newton meter divided by hertz. Hertz is unit of frequency, which is equal to 1 upon second. That means Newton meter, and second goes up, becomes product of Newton meter, and from here Newton meter second, you can do same work that we did in the previous way. You will have the same answer. Option is A. Question 8 and 9 refers to the following information. Pulse echo technique can be used can use ultrasound. When the ultrasound pulse reaches the boundary between two material, part of it is reflected and then detected. The oscilloscope screen below shows transmitted and detected pulses. So this is the transmitted one, detected one. The speed of ultrasound in the first material is V. Each division on the oscilloscope screen represents 10 microsecond. What is the approximate thickness of the first material? A typical question of pulse and echo technique. And in pulse echo technique, we use formula S is equal to UT. U is the speed of wave or pulse. T is the time difference, sending and the returning. And S is the distance covered. Again, be careful in pulse and echo technique. This is just not a distance. This is double of the distance. So 2S is equal to UT. We always use double of the distance because of the pulse and echo. Like this is the transmitter sending and then reflecting back. So if one way distance is S and then S, so total is 2S. So we always use double of the distance. So 2S is equal to UT, and this in this case, this S will be showing thickness of the material. So S, which is the thickness, is UT upon 2. U is the speed of the ultrasound, which is V, and T is the time interval between pulse transmitted and the detected pulse. And if you see, this is transmitted and detected, and you have 1, 2, 3, and 4 squares, and each square is 10. So total time between these two is 40 microsecond, and micro means 10 to the power minus 6 second. So V into 40 into 10 to the power minus 6 divided by 2, and you can cancel 2 and 40. So V into 20 times 10 to the power minus 6 divided, 2 is gone. So V times 20 times 10 to the power minus 6. So your option is yes, 20A. Question 9. An ultrasound pulse and echo technique is used to produce an image by reflection from many boundaries. It is if the transmitted pulse is too long, the image produced is of a poor quality, and this could be because of I have already shown my mistake. So, but it is C. Why is that? Because if a transmitted pulse is too long, that means it will take time. It will take a shorter time to return. So meaning, because of the too long pulse, the second pulse will be sent before even returning the first one. So definitely, because the first one is not returned properly, so image will be poor quality. So the time interval between transmitted and the detected and the second one is too short. That's why it is C. The resistance of a thermistor decreases as temperature increases. It is used in a circuit to switch on a heater as the temperature falls. The heater will switch on when the potential difference across it is greater than the certain value. Which of the following circuit would do that? Clearly, you can ignore A and B because thermistor and the resistors are connected in parallel, so this circuit will not work as a potential divider, and the heater will not be affected by the thermistor in option C, because the voltage across heater always remains equal to the EMF, so there will be no change in the EMF or potential across heater. And the easy way is, because we need to control temperature with the help of thermistor, so we should attach heater with the thermistor. So if due to change in temperature, resistance of thermistor changes, so the voltage across thermistor is going to change. That's why the voltage of heater is going to change. So option is A. Question 11. A right-angled glass prism may be used in an optical device to deflect a ray of light through an angle of 90 degrees. The light enters the prism along a normal and is totally internally reflected as shown. So this is incident light, total internal reflected into the glass and returns. State a necessary condition for light to be totally internally reflected at boundary between the two materials. So condition for total internal reflection there are two important conditions, that the transmission or the refraction should be from denser to rarer medium, or high refractive index to low refractive index. If refraction is going on from high to low, then we can have a chance of total internal reflection. This is the first condition, because from rarer to denser, there will be no choice or no chance of total internal reflection. So this is the first condition, from denser to rarer. And the second condition is incident angle should be greater than critical angle, so that the light is totally internally reflected. Part B. A drop of water forms on the outside of the prism. Okay, this is water drop. Determine whether all of the light will still be deflected through 90 degree by prism. Speed of water in 2.25. Speed of water is 2.25 and last. Okay, so in this case, remember, we are dealing with two different material. Because light is coming from glass, so I'm going to call this glass is material 1 or medium 1, and the water is medium 2. And we have two different methods to determine the condition. The one is finding the refractive index and then compare. And for me, because incident angle is given and speeds are given, so it is easy to understand and to determine the condition. And what I'm going to do is I'm going to use the relation n1 sine theta 1 is equal to n2 sine theta 2. Remember, this one showing about medium 1. So refractive index of medium 1 and angle in medium 1. Refractive index of medium 2 and angle in medium 2. So I can rearrange this equation as n1 upon n2 equal to sine theta 2 over sine theta 1. It's 1. I have a similar relation between the speeds, like n1 v1 equal to n2 v2, and I can rearrange n1 v1 n1 over n2 divided by v2 over v1. So easily you can compare right hand side of the equation and you can write that sine theta 2 divided by sine theta 1 equals v2 over v1, and then I'm going to figure out the value of theta 2 and then compare with this. So I need to make theta 2 as a subject. So theta 2 is sine inverse sine theta 1 v2 over v1. So v2 is speed in medium 2. This is v2, and v1 is the speed in medium 1, which is this v1. And what about theta 1? Theta 1 is the angle in medium 1. If you see in your diagram, this is your median 1 and this is the boundary, so you can visualize a normal line, and this is the angle in medium 1, and of course if you use your geometry, this is 45, this angle should be 45. So theta 1 is 45. So you can plug in the value theta 1 as a 45, v2 is 2.25 10 to the power 8, v1 is 2 10 to the power 8, and if you solve this, the value of theta 2 would be 52.70. That is, if you round it off, theta 2 is 53 degree. That means theta 2 or 53 degree is less than 90 degree. So it won't be deflect. Thank you very much. Have a nice time.